This is our marshmallow roasting machine. So we got an arm here connected to this stepper motor that will hold the marshmallow over a flame or whatever kind of heat source you like to use to roast your marshmallows. And it will adjust the height to keep a temperature right here at this thermocouple consistent, so you get a nicely evenly roasted marshmallow.
We have this 3D printed gearbox with some different mechanisms here so that it can rotate effectively, and if it goes too far down, the default is if you shut the motors off, it'll go back up and not fall into the fire, which is a safety measure. It also has a few photo interrupters to tell when it's too far forward, and then it'll stop roasting, or if it's too far back, it'll be in the home position. You can set the time of how long you roast it with this 3D printed LCD box. So right now it just goes back to the home position, where ideally you're right here and your campfire is here, and you have your marshmallow makings. You put on your marshmallow, you set the time to however long you want, and then you press start stop, and then it should automatically rotate the marshmallow every few seconds to get an even cooking temperature, and then go down.
The bouncing is it hitting the lower limit, so it's not going into the fire. And then when it gets too hot, it'll raise itself up from the flame.
So we'll demonstrate.
And whenever it stops, it's at the optimal temperature to roast at.
This is what it looks like on an actual fire. It goes down, gets to about the right temperature, and once it's at the right temperature, it'll stay there until it gets too hot, and then it'll move back up to cool down a bit. And so that little bouncing is when it's getting to the end of the photo interrupter. This is the max distance. You want it to not go so far that it can actually hit the fire. So you can set that to be about where the fire is, so it can't get overly roasted or on fire. Once you're done, or if you think that it's done already, you can hit the start stop button again. It'll go back to the home position, new time, and just go ahead and hit start again, and you can do it for another one. This gearbox, it's held by this counterweight and these tensioners to make it so that its default position is somewhere between here and here when there's no torque on the motors. Just a stepper motor hooked up to a custom 3D printed herringbone gear. This herringbone gear has different places where you can put the thermocouple, so it has like different configurations for where you might want to put it. So here is actually just a little bit lower servo, so it would spin continuously. We have some bearings going here to make it so it spins a lot smoother. So we have an easy driver running the stepper, which is just a bipolar stepper. And we have max 31588 amplifier circuit for our thermocouple. And that goes directly into the Arduino Mega, which is running everything, and then the pick is just running the music. There's also a volume knob on the music. If you want it to roast a little bit higher, you just bend this a little bit more in, and it'll roast a little higher. If you want it to roast a little bit farther out, you simply bend this out, and it should detect a little later. Same with this home switch. You can set essentially where you want it to home to, if you want it to home down here or up here. And that's just this optical sensor on the back. You can see it right there. It goes to that little flag.